Hi everyone, this is Matt Show with Intro Stats, and today we're looking at a problem from my book, Intro to Statistics for Community College Students. This is section 4D, as in dog, number 26, and this is the goodness of fit test section. So let's take a look and read the problem. So it says it's a big job to write and grade the AP Stat exams for high school students each year. It's a difficult multiple choice exam. All questions have 5 possible answers, A through E. Use a 5% significance level in the following sample data to test the claim that the percent of A answers is the same as B, same as C, same as D, same as E. This would indicate that the letter of the answer is not related to the percentage of times it happens. You can assume that the sample data meets the assumptions. Type the following sample data under the Edit Data menu of StatKey. Okay. So notice they actually showed you how to type it in case it's not a preloaded data set. You can type it into StatKey this way. So we're going to go to lock5stat.com and we're going to click on StatKey. The goodness of fit test is down at the bottom. It says chi-square goodness of fit. It looks like a squiggly X. It's really the Greek letter chi-square goodness of fit test. So that's the button we're going to click on. Okay, and again, we're looking for AP. It may be a downloaded, yeah, it's already in there actually, AP multiple choice. There's the data right there. So we don't have to type it in, though we could type it in ourselves if it was not there. They actually have the raw data there. So it's already typed, we could type it in, but it's already done for us. And there's our chi-square test statistic, 3.426, right there. Now if I want to see the details, again, with goodness of fit tests in chi-square, where you're looking at expected counts versus observed counts. If you can see here, we can see the first number is the observed. That's how many times it actually happened. What we expect to happen if the null hypothesis was true. Remember, the null hypothesis is that the 5 letters for the AP Stat exam multiple choice are all equally likely. So 400 divided by 5 would be 80. So that's where they're getting these second number, the middle number is the expected counts. And they're all above 5, right? So that's a good sign. The third number, by the way, is the contribution to chi-square. These are the numbers that got added up to get the chi-square test statistic. Okay. Let's take a look at the null hypothesis. So we'd probably write this as P1 equals P2 equals P3 equals P4 equals P5, or sometimes you might say pi if you're using a class that's using pi for the population percentage. So pi for A equals pi for B equals pi for C equals pi for D, which equals pi to E. If you notice though, what StatKey did is they wrote them all as 20%, 0.2. And that just means they're all equal. Of course, if we take 100% of the numbers and divide them into 5 equal groups, we should have 20% in each group. So that's kind of the idea of equal to. All right, so let's simulate the null hypothesis. So we're going to click 1,000 samples very quickly here. A few thousand, doesn't take very long. We learned that goodness of fit is a right-tailed test, so we're going to click right tail. They said in the problem that they wanted us to use a 5% significance level, so let's do that. So I'm going to put 0.05 in the tail. 0.05 in the tail. There we go. So it looks like this simulation is indicating, now these are thousands of chi-square. You can kind of see that the chi-square distribution is skewed right. We kind of knew that. And again, it shows us that this would be a critical value here, that the chi-square test statistic needs to be 9.7 or bigger to be considered significant. Well, does our original sample chi-square test statistic fall in the tail or not? Well, here it is. Here's our original sample. This is the real one. The chi-square test statistic was 3.426. That's definitely not in the tail, right? 3.426 is way over here. So it's definitely not in the tail. That means not significant. So our sample data does not significantly disagree with the null hypothesis. If you remember, your observed counts is your sample data, your expected counts is your null hypothesis. So this is also telling us that the observed counts are not significantly different than the expected counts. They're actually closer. So what does that tell us? All right, so the sample data again does not significantly disagree with the null hypothesis. Now what about our p-value? Now this is not a p-value, this is the significance level. So I need the probability that associated with this original sample data. So I'm going to type in the original 3.426 in this bottom box right here. 3.426. And that was the original sample chi-squared test statistic. So the probability of getting the chi-squared test statistic or more extreme, if the null was true by sampling variability, is 4.96 and our 0.496, which is our estimated p-value. Now remember, these numbers, when you do your simulation, you will get something probably a little bit different than what I'm getting with this simulation. Remember, principle of sampling variability is random samples are always different. So my random samples are not going to be the same as when you do this on StatKey. You might get slightly different answers here. We'll be close, but we will get slightly different answers. So just be aware of that when you're looking at an answer key. It won't be exactly the same. But we do have a very high p-value, right? 49.6% p-value. That's a really, really high p-value. Definitely higher than our 5% significance level. So this could just be sampling variability. The null hypothesis, if the null hypothesis was true, this sample data could have occurred just because of sampling variability or random chance. That means we're going to high p-value, right? So that means we're going to fail to reject the null hypothesis. We're failing to reject the null hypothesis. Now, what does that tell us about the claim? Well, let's see, our claim was that, let's see, we're claiming, test the claim that the percentage of is the same. So the null hypothesis actually was the claim. So the null hypothesis was the claim, not related. And we're failing to reject the null, which means there's not significant evidence to reject the null hypothesis, right? There's not significant evidence to reject the claim that the percentage of A answers is the same as B, C, D, and E. Again, the high p-value is kind of indicating not related. That's kind of, usually low p-values indicate more of a relationship, high p-values indicate not related. This could just be sampling variability. Okay? All right, so this is Matt Touchot and Intro Stats, and this was section 4D, D as in dog, number 26.